Today I'm going to discuss Arduino Uno. So Arduino Uno is a development board. This is the Arduino Uno board. So it's a development board which can be easily interfaced with the laptop by using this USB port. So this is the controller we have used in this Arduino Uno board. So Atmega 328. So this is a 28 pin IC. So we can just see these ports. So these are the digital pins actually. So 0 to 13. So these are the IO pins actually, input or output pins. And we have analog pins A0 to A5. 6 analog pins will be there. And these are the power pins like 5 volts. We have the power source of 5 volts, 3.3 volts, and ground pin will be there. And we can observe this is the reset button, and this is a power jack. So we can use any external power source by using this power jack. And this is a crystal oscillator, 16 megahertz crystal oscillator we are using. So this is a crystal oscillator we have to connect externally to the IC. So this IC is these pins are interconnected with this IC. Okay, let's see the specifications of Arduino Uno. So here you can see the microcontroller is Atmega 38. So Atmega 38 is the microcontroller we are using in this board, Arduino Uno board. And this Atmega 38 is 28 pin IC. So this control we have 28 pin. Okay, and next the operating voltage is 5 volts. So this 5 volts is for the IC, not for the board. So input voltage is 7 to 12 volts. So this is external power supply, not USB. Okay, so whatever the power I have already discussed now. So power jack. So for this power jack we can use the power source of 7 to 12 volts DC. Okay, and next we have digital pins. So digital IO pins means input and output pins. We have 14 digital pins. So these pins will be represented as 0 to 13, of which 6 provide PWM output. So in these 14 digital pins 0 to 13, we have 6 PWM pins. Okay, so 3, 5, 6, 9, 10, 11. So we can observe this a tedal symbol will be there before the pin number. So this symbol will represent the PWM pins. So normally these PWM pins mainly used for speed control of a DC motor. Okay, so we can control the speed of a DC motor. It will be normally like robots, something like that. We use this speeding control like that. So and one more thing is LED fading or brightness controlling. So these PWM pins will be used for brightness controlling and the speed controlling of a DC motor. So these IO pins can be used to interface with any digital sensors or modules. Okay, and next we have analog pins or 6. So we have 6 analog pins. So that will be written as A0 to A5. So these are the analog pins A0 to A5. So we have 6 analog pins. One more thing we have in these analog pins, we A4 and A5 is basically used for I2C communication. So we can use it for both actually. Two features will be there. One is for analog pin, like we can connect any analog sensor to this A4 and A5. And one more thing, if you are using any I2C model sensor, then we have to use this A4 and A5. So A4 is represented as SDA, like serial data, and A5 is SCL. So normally is called as serial clock. So we have totally 14 digital pins and 6 analog pins, totally 20. Okay, here we can see, observe that one more thing, one more point. DC current per IO pin is 40 milliamp. So for digital pins, it can produce, the controller can produce the current rate of 40 milliamp of current rating. So normally why we basically we are providing this means, so if you are controlling any DC, if you are connected any DC motor, then it can't able to drive the DC motor. So with 40 milliamp, if you want to use the DC motor something like that, then we have to go with the modules called L293D. So that is the IC. So by using that IC, we can interface the DC motor with the controller. Okay, so that is not our topic now. So let's move on. Flash memory of 32 KB. So for Atmega 38, we have the flash memory of 32 KB. So this is the memory where we store our program actually. So our program will be stored in this flash memory. So here we can observe that one more thing. So of which 0.5 KB used for bootloader. So actually this is bootloader is given by the manufacturer only, by the board when we buy board actually. So 0.5 in this 32 KB of KB, 0.5 KB is used by bootloader. Okay, so remaining 31.5 KB. So this will be our application program. Whatever our wrote the program, but will be stored in this 31.5 KB of data, like in this memory. And next we have SRAM, like static RAM. We have 2 KB of memory. So this memory normally used for temporary memory, like when we on the runtime. Actually this memory will be used on the runtime when we run our program. When we start our when the board starts the program, then it will use this memory actually. So like to store the local variables data, something like that. And next we have EEPROM. So EEPROM is nothing but electrical erasable programmable read only memory. So this is normally for to store permanent data. So we have the memory size of 1 KB. We can store 1 KB of data in this IC. This feature is there in inbuilt of the IC actually. So normally if you want to use store any permanent data like that, we have to use the EEPROM ICs externally. But in this administrated we have inbuilt. So we can directly use this 1 KB of data in the IC itself. And one more thing, we have clock speed crystal oscillator of 16 megahertz oscillate. So this, for every controller we should have to give the oscillator. So we are using the crystal oscillator of 16 megahertz, should be connected externally for this IC. Okay, so can raise a doubt like what is an oscillator actually, so why we have to use this. So normally for any controller we have to provide the oscillator. So this will be specifically for the actually like timing purpose. When we want the time, if you want to count a time, okay, so then we need this oscillator like timing delays. We have to like for second, if you want 1 minute of time delay, then for that we have to use this oscillator. Normally this is for timing purpose actually. Okay, next, so this is connected externally. Okay, so let's move on to the next slide. So this is our board, and uh, we can observe all the pins over here. So have to discuss the pins one by one. So you can observe that. So 0 to 13 is the digital pins normally. Okay, so normally 0 and 1 is represented as 0 is represented as RX receiver actually. So 1 is TX transmitter. So 0 and 1 is normally is a standard UART actually. So standard UART means universal asynchronous receiver and transmitter. So this UART pin is used for serial communication. So whatever the program we write in our laptop, that will be we have to store in this Arduino, like this controller. Then by using these pins only, our program will be dumped into this IC. So this will be burned in our IC by using these pins only. Whatever the USB were connected to the laptop, by using this USB pin that internally connected to 0 and 1. So this 0 and 1 is connected to controller. Then whatever the transmitted data, that is our program actually, that is in X file. That X file will be transmitted to IC by using this 0 and 1 pin. So if you want in connect any serial module, okay, like GSM, GPS, something like RFID, so then we can use directly this 0 and 1. So if you want more than one, for suppose we have GPS module in our project, for suppose GPS and GSM module is you are using, for suppose, so both are serial communication. If you connected one module to 0 and 1, so another module is there, so we don't have any other UART port. So there is an advanced feature is there in Arduino IDE, so that is software serial library. So this is by using this library we can convert any digital pins in this 0 to 13 except 0 and 1. We can from 2 to 13 we can convert any digital pin into serial communication. For serial communication we need two pins. So if you for suppose we are using 2 and 3, so by using the software serial we can convert this 2 and 3 to serial communication. Then we can use the GPS module also. If you have more than two also, then we can convert any distance. We can convert any like we can more than two also. We can use this library actually. Okay. So one more thing I have to say in this digital pins, one more feature also is there. So this is SPI. Normally is SPI. SPI means serial peripheral interface. So this protocol will be used for specific modules actually. So for this we can give an example as SD card. So for this we have four pins actually. Okay, so clock, MISO, MOSI, and select device SS. Okay, so these four will be connected to the module. Like if, for example, you can give this as SD card module. So for that is an SPA protocol, then we have to use this 13, 12, 11, 10 digital pins only. Okay, that is for the SP protocol. And in this board we have another protocol we can use, that is A4 and A5, that is I2C communication. So SDA and SCL. Okay, so I can give the example for a I2C communication is MPU 6050 is the model of accelerometer. So that is an I2C communication acceleration actually. So in this board, like in Arduino, we can use these three protocols. One is UART, one is SPI, one is I2C. Okay, so if you want use more than more than one module serial communication, then we can use the software serial library in the Arduino IDE itself. Okay, so and one more thing I have to say, like this is the power pins, 5 volts. If you are using any sensors, then we can take the power supply from 5 volts from here actually. Okay, 3.3 volts. If you want any, some modules will have actually 3.3 volts power supply, then we can use this directly 3.3 volts. So okay, so this is the pins things whatever the using here. And one more thing is the pin diagram of Atmega 328. So actually I have said that we have this controller, we have digital pins and analog pins. So normally these representation for the development board only, so not for the IC. So if you go with the ICs, okay, like Atmega 328 microcontroller, then this will be like this actually. So 28 pin, one side will have 14, one side will have 14. Okay, so I'm telling that digital pins. So these are the digital pins D0 to D4, like 0, 1, 2, 3, and 4. So these pins will be port D actually. So this 0 to 4 and 5 to 7 pins, that will be called as port D. Normally internal structure will be called as port D. Normally I'm telling as digital analog, but it will be differentiated with the ports actually. So that ports are port D. So port D is for digital pin number 0 to 7, and digital pin number 8 to 13 is for the port B. So we can observe this B0. So that is for 8 pin in digital pin number 8, B0, B1, B2, B3, B4 and B5. This is port B. We have three ports. So one is port B, port D, and one more thing is port C. Port C is normally for used for totally analog pins, A0 to A5. So we have three ports. One is port D, port B, and port C. So port D is started from 0 to 7, digital pin number 0 to 7, and port B is from starting from digital pin number 8 to 13, and port C is totally analog pins A0 to A5. Okay, so thank you for watching.